Hey there, ladies and gentlemen, boys and girls. Today, we're going to talk about chemical nomenclature. All right, chemical nomenclature is just a fancy word for the naming system we use to name certain chemical compounds. All right, this is kind of the first of two videos of the different types of naming. And I say two videos because we're going to talk about the two different types of chemical bonds. All right, there is an international set of rules on how to name certain chemical compounds. And I'm going to show you guys a little bit of how to do that today. So what I'm going to do here is I'm going to show you first the rules to go from the chemical formula and how we turn it into its chemical name, or if I was given the chemical name, how to show its formula. But today, this video is going to be, like I said, the first of two, because today we're going to be focusing on how to do it for ionic compounds. All right, there's a different set of rules for covalent compounds. All right, I'm going to say this in probably both videos. The very first and most important step, all right, is first identifying which set of rules are we using, because we need to identify, is this ionic or covalent? All right, it's the most important step. It is also the step that people miss the most. So they have a covalent or ionic compound and they use covalent rules for naming. All right, so I'm going to show you guys kind of the quick set of rules, and then we'll do a couple examples real quick. All right, and I'll talk about where kids make mistakes. So if you need a moment to kind of copy this down, go ahead. I'll pause right now. And we're back. Okay, hopefully pause so you can put it in your handy dandy notebook. First step, like I said, the most important stage is that we are talking about ionic compounds. Right? The set of rules that we're going to talk right now is for ionic compounds, and that it means that we have a metal and a nonmetal. All right? That is extremely important that we talk about what we're talking about, metals and nonmetals here. All right? If we have a metal and a nonmetal, these are what we need to do. So let's start my idea of going from a chemical formula to its name. So for right here, example, this one right here, Na2O. That is a chemical formula. I'm going to show you guys how to write its chemical name. All right? So, to go from chemical formula to chemical name, it's actually quite easy. All right? Step one, you name the metal first. All right? So for example here, we'll kind of work through this example here. The metal goes first. Na is sodium. The metal always goes first. Good. Nice and easy. The second step. All right. So you're going to add IDE. It's a suffix, means it goes at the end of the word, to the nonmetal. So oxygen becomes oxide. Nitrogen becomes nitride. Right? Fluorine becomes fluoride. Bromine becomes bromide. Iodine becomes iodide. All right? Some of them are a little bit easier. Fluorine to fluoride is pretty easy. Oxygen into, it's not oxygenide, it's oxide, because you have to take off the part and add the IDE. I will help you kind of as we go through some of these practices, all right? But I have sodium oxide, all right? So this right here, Na2O, sodium oxide. Pretty straightforward, pretty easy, all right? Two steps. You literally name it, or put the metal first, and add IDE. All right? Now, going backwards, this one's really easy. That's super straightforward. This one, this way, going the other way, is actually kind of tricky here. All right? The steps aren't very hard, but I will talk about where you make the mistakes, where the mistakes will be made, I should say. All right? To go from the chemical name, like aluminum chloride, back into the chemical formula, all right? All you have to do is, again, the metal goes first. All right, so aluminum becomes Al. All right, followed by the Cl. All right, for chlorine because the metal goes first. All right, but now here's where it's tricky. You need to add the subscripts. That's the little numbers. Like this 2 right here is the subscript. That subscript tells me how many sodiums there are. All right? You need to add subscripts. Based on their charges. All right, remember, we want them to be neutral when we make ionic bonds. All right, so what do I mean by that? All right, aluminum forms a +3 cation. Chlorine forms a -1 anion. If I did this as the actual Lewis dot structure, right, that's 3 valence electrons. Chlorine has 7. So I'm doing kind of small, kind of fast. We know that I'm going to need 3 different chlorines to do that. All right, that's what its Lewis dot structure will look like. But notice it doesn't say that here. Let me show you the shortcut. This only works for ionic. Only for ionic, and here's the shortcut. All right? You got to be very careful, so listen very carefully here. That's a +3. That's a -1. Take just the number. So a +3, the 3, just the 3, not the plus, just the 3. And you're going to cross it over here. All right? And then you're going to take that -1, not the minus, just the number, just the 1. You're going to cross it over here. But you don't have to show the 1. That's what happened. Aluminum and 3 chlorines, aluminum chloride. Notice I did not do +3. No. That's a charge. This is just a little trick that we can do. It's called the crisscross method, all right, of showing charges just for ionic. All right, so like let's do that example. Let's do another example here. All right, magnesium oxide. That's Mg for magnesium goes first. All right, oxygen goes second. All right, oxide being oxygen. All right, now we need to add the charges or subscripts. They need to be neutral. All right, so for example, right here. I have 3 -1 chlorines. I technically did 3 -1s to make out that +3. 3 -1, or now I have -3, +3, that makes 0. In this case here, magnesium is a +2 cation. Oxygen's a -2 cation. If I do the crisscross method, that 2 would go down here. This 2 would go over here. All right, but now here's an extra part of the trick of this. All right, those 2 and 2, we can always simplify or reduce. Think about math class. 2 and 2 can simplify into 1 and 1, which we don't show the 1s. That's what. If that is too complicated, if that's still too struggle, then just do this. All right. Okay, magnesium has 2 valence electrons. Oxygen has 6. This one will give 2 electrons to this one. Everyone's happy. I used 1 magnesium and 1 oxygen, magnesium oxide. You can do either way. You can either do the crisscross method, or you can just do what we've been practicing with ionic bonds. Either way, it just shows the number of them. All right. The number 1 mistake students will make is they will see aluminum chloride and they will just give me that. It is incorrect. Aluminum chloride has 3 chlorines per 1 aluminum. All right. That's the only part that's tricky. This one's really easy, and this one's not that hard if you just take the extra time to think about it. But both of these are an example of metal and a non-metal. All right, you're going to have lots of practice do this, and we're going to do some more in class. So I'm going to stop it right here because I want to do the second part of the video about covalent compound or molecules. Otherwise, good luck, and may the science be with you.